The proof that there are infinitely many primes is a proof by contradiction that is 2,000 years old. It's quite a straightforward problem, and its solution has far-reaching consequences. So, how do we do it? Well, if we're going to prove that there are infinitely many primes, and we're going to do this by contradiction, then we're going to first assume that there are finitely many primes, or there is, rather, a finite list of primes. So I've figured out all of the primes, and I can write them in a list: P1, P2, P3, all the way up to the last prime, the largest prime, Pn. Okay, I have my list of primes. Now, let's invent a new number, P, and say that P is the product of all of these prime numbers, so P1, P2, P3 times all the way up to Pn, plus 1. So clearly, P is larger than any of those primes that came before, okay? Now, this isn't to say that P is prime, but P could be either prime or not prime, okay? P is either prime or not prime. Okay? So P is either a prime number or it's not a prime number. Okay, so if P is prime, then P is clearly not in the list. Okay? As P is greater than all of the primes that have come before. Okay, so if capital P is prime, then capital P is not in the list. And so, in that case, we have found another prime. It's not in the original list, and so there must be infinitely many primes. However, if P is not prime, then that would mean that we can divide capital P by one of the other primes. Okay? It's through the prime factor decomposition where every whole number is a product of a product of primes. This would mean that P, so if P is not prime, then P has a prime factor. Okay, so one of those P's that are in my list must be a factor of capital P. Okay? However, that would mean, because clearly, if one of my P's, whichever P it is, will be a factor of this, but it would also need to be a factor of this. So the prime factor that I found must be a factor of 1. But because P is a whole number, that's impossible. Okay? So, because we cannot have this prime number being a factor of 1, okay, we have found a contradiction. Therefore, our original assumption that there was a finite list of primes must be false. And so there must be infinitely many primes. Okay? So it's this part that the whole proof hinges upon, okay? So if P is prime, then we've found another prime that is not in the original list, okay? And so that then means that the original assumption was false. If P is not prime, then P would have to have a prime factor which must be a factor of 1. And we can't have that. No prime factor is a factor of 1. Okay? So because that is impossible, we therefore have a contradiction. P cannot be prime, and it doesn't work if P is not prime either. Okay? And so the original assumption that we had was false. And so there must be infinitely many primes.